This is the Calculus Pre-Lecture Series. I'm Caitlin Murphy, and this podcast is on comparison tests for series. First, we'll recall end behavior. So, end behavior is the trend of the function as x approaches positive or negative infinity. So, say, you may have heard this before in an algebra class, if you took an even function, say f of x equals x squared, then you said that either the end behavior as we went x goes to negative infinity, or as x goes to positive infinity, would be going to infinity. Or if you had f of x equals negative x squared, we'd say both as x goes to negative infinity or positive infinity, our function values go to negative infinity. Okay? So end behavior only really matters as we go really far out, as x gets really big, as it's approaching infinity. We just want to know what's the overall trend of the function as x is getting really big. And we're going to discuss a method of proving convergence or divergence of series by comparing the end behavior of different series. So first we need two series to be able to compare. So we have some conditions. The conditions are the terms of our two series, we'll call them series A sub n and series B sub n, must be positive. Second, there has to exist a number, we'll call it big N, such that for all little n bigger than big N, A sub n is greater than or equal to B sub n is greater than or equal to 0. That just means that eventually there's a point where after some point, that big N can be a really big number, it could be 500 or 1,000, but after that, the A sub n terms are always bigger than the B sub n terms, every one of them. So the end behavior of A sub n is, in a sense, bigger or higher than B sub n. Okay. Then we have two possible conclusions. One is that if A sub n converges, so remember that's the series with the bigger terms, if A sub n converges, that forces the sum of B sub n to converge. And second, if the sum of B sub n diverges, so that's the smaller, in a sense, end behavior. If B sub n diverges, it forces the sum of A sub n to also diverge. Okay, so we're going to use this method. We're just comparing the end behavior of two series. So if the smaller end behavior diverges, it forces the bigger end behavior to also diverge. In a sense, you can kind of think of it as pushing it up. And then if the bigger end behavior converges, it forces the smaller one to also converge. And that's how we can use the end behavior to compare two series to see if they converge or diverge, and we call that the comparison test.